All right, so Friday's assignment was fun with phases, but there were several videos that you looked at that some of them only had music, some of them had a little bit of explanation, some of them had some, somebody talking, etc. But there's a couple of things that I'd like to go through since you were watching them and I wasn't really talking you through them. So the first one we're going to do is the lunar eclipse time-lapse video. We're going to talk just a little bit more about some details about lunar eclipses and what those are. Okay, one of the first things that you need to know about lunar eclipses is that they occur only during full moons. So this is what a full moon would look like. During a full moon, remember, the moon is on one side of the Earth and the sun is on the opposite side. Okay, and the entire illuminated part of the moon is the side that faces us. Of course, the moon and any other object that is reflecting sunlight is only 50% illuminated at any time. But in the case of a full moon, the entire side that's illuminated is what's facing us. So I'm going to click, this is on double speed. And what I want you to notice is that we have the Earth's shadow start to kind of creep over the moon. That's what's happening right here. What's really happening is the moon is slowly moving into the Earth's shadow. And as that progresses, it's not going to actually disappear. The moon's going to turn kind of an orangey red, and that is just simply because there's enough light that is being refracted by the Earth's atmosphere that it still hits the moon a little bit. So it's mostly red and orange wavelengths of light, which is why that it's red and orange. Because the moon is sitting right now in the Earth's shadow. But again, it's illuminated a little bit just because some of the light is refracted by the Earth's atmosphere. Okay, so I want you to understand this occurs always at night during a full moon, and it occurs because the moon moves through the Earth's shadow. They're rare because everything has to be lined up just right in order for a lunar eclipse to occur. Most of the time, the shadow of the Earth misses the moon and we don't have an eclipse. And that's because the moon's orbit around Earth is tilted about 5 degrees versus what the Earth's orbit around the sun is. Okay? All right, the next one I want you to look at with me real quickly is the one about the midnight eclipse. So let's pull that one up. All right, this one is interesting because not only is it showing you a partial solar eclipse, but it's showing you a solar eclipse. If you caught that, it says a midnight solar eclipse. Well, how is that possible? Because solar eclipses will only occur during the day. Well, this particular eclipse occurred in northern Norway in a little town called Alta, and they are at about 70 degrees north latitude. So they are inside the Arctic Circle. And you noticed if you were watching, they said that this occurred in June, which is near our northern hemisphere's summer solstice. So the days are very, very, very long. And quite frankly, if you're within the Arctic Circle, your days can be continuous because the sun will never set. So what you wind up seeing in this video is that the sun sits there and moves around the horizon rather than setting below the horizon. And that little cookie bite that is missing is where the moon is partially covering the sun. I like this eclipse just simply because it's unique. It's something that we wouldn't see here in Texas because we're not far enough north to watch the sun move around the horizon rather than set. Okay? Okay, and just to give you an idea of where Alta, northern Norway is, here we are. And I am talking about right here. Okay? And that is way, way, way up toward the North Pole. Okay? I'm talking about a little area right there. Okay, I'm skipping around just a little bit. This is actually the last of the 8 videos that were posted on Friday. And this is just a continuous kind of time lapse of all the moon phases and when they occur in 2020. If you notice down here, it will tell you the date and the time. If you look really carefully, there's a little moon icon right there. Here's the Earth icon. And you'll notice that sometimes the moon is a little bit further away from the Earth. Other times the moon is a little bit closer to the Earth, but it kind of tends to oscillate like back and forth, depending on where it is in its orbit, because sometimes it's a little bit closer to the Earth and sometimes a little bit further. Just for fun, they put a bunch of the landmarks on the moon. Over here, they're showing you what the angle between the sun would be down here somewhere because this side is illuminated. Here's the Earth, here's the moon. So the sun being down here, Earth, moon, we're almost at a 90-degree angle, so we're getting close to first quarter. And you can watch where the moon is in its orbit versus what it looks like with the moon phase. And so waxing gibbous, the moon gets back here, it's basically full, okay, because remember the sun's rays are coming in from this direction, okay, so, and then if you continue, now we're at waning gibbous. Remember, gibbous means that it's more than halfway illuminated from our perspective, but waning means that it's getting smaller and smaller each day. And then you get back to about here, and that's last quarter because we've gone 3/4 of the way around. This would be waning crescent. So you start seeing just a little sliver, and then back to new. Okay, and it's going to continue to play and show you the moon phases for the entire year of 2020. But one of the things that, like I said, I wanted to point out was this little thing. Sometimes the moon's a little bit closer to us, sometimes it's a little bit further than us. And just like any object, when the object is closer to you, it appears to be larger in your field of view. When that object is further away from you, it appears a smaller portion of your field of view. And that's important to remember with the moon because we're going to talk about eclipses in just a minute. And if the moon's a little bit too far away in its orbit, then rather than a total solar eclipse, we'll get something called an annular eclipse, which is where I want to go next. Okay? All right, an eclipse is simply when one celestial body, either a planet, a moon, something like that, is temporarily obscured by another celestial body, planet or moon. Okay? So our two main varieties of eclipses are solar eclipses and lunar eclipses. If we have a solar eclipse, it is because the moon moves, from our perspective, moves in front of the sun, meaning that we're lined up, sun, moon, earth, with the moon directly in the middle casting a shadow on earth. If we have a lunar eclipse, that's going to be when the earth sits straight in the middle and the earth is casting a shadow on the moon. We can actually also have little planets that move across the sun, but we don't call those planetary eclipses. We call those transits because they don't obscure very much of the sun at all. Okay. All right, so I'd like to show you the two main types. Okay. Let's see. Here we go. All right, lunar eclipses, like we said, full moon, moon passes through the Earth's shadow. You saw that in the time-lapse video earlier. Okay. And then we've got solar eclipses where the moon is actually directly between the sun and the earth, and the moon is casting a shadow on the earth. Now, the moon is fairly small, and its shadow is going to be fairly small on the much larger earth. So for a solar eclipse, you really have to kind of be in the right place at the right time. It's very rare to be able to catch a solar eclipse. Okay? And conditions have to be just perfect for you to get an actual solar eclipse and not an annular eclipse. So we're going to talk about that in just a second too. All right, so you've got three types of solar eclipses. You've got a partial, a total, and an annular. Partial is when you don't have everything perfectly lined up and maybe the moon just covers part of the sun. Okay? Then you have a total solar eclipse where the moon covers the entire surface of the sun and all you see is this wispy little corona outside of it. And then the last type is your annular eclipse. Okay, partial, total, and then annular. And in 2012, I actually went and looked at an annular eclipse, and it was this one. The guy that was making the video was talking specifically about the 2012 annular eclipse. And so I'll show you a couple of photos from that. All right, so first of all, here we all are looking at the eclipse with our little visors. You can't look directly in the sun or you will fry your retinas. But we have all these little pieces of equipment. There's my little telescope with its solar filter, and I had to have a filter for the camera and everything. But once I put the filter on, let me show you what it looked like. All right, here's towards the beginning when you can just see a little bit of the moon obscuring the sun. And again, this is in broad daylight, but the solar filter has got to block out almost all of the sunlight so that you're just left with a little bit that's enough for safe viewing. Okay, so like I said, the image is pitch black, but it is actually during the day. All right, here we go. A little bit more time has gone by, and the moon has moved further in front of the sun. Here we go, and there we go. There's the moon directly in front of the sun, but it's not large enough in our field of view to completely cover the sun. So you're left with that ring. That's why it's called an annular eclipse. Annulus, I think, is some Latin word that means ring. But that's what an annular eclipse looks like. Now, during totality, it's not even really called totality, but during maximum eclipse, you still have got to keep your eye protection on because there's still enough sunlight just from this ring that can still cause eye damage. Okay, so here, this is actually, I did this by kind of looking off but pointing my camera towards the sun and taking the filter off. You can see that even during maximum eclipse, the moon is sitting in front of the sun in this image, but you can't even tell because it's completely obscured by the glare. So you still have got to wear eye protection because it's still this bright. Now, it's not as bright as it was during, a normal day, but it's still very bright. Okay, and then, of course, the moon keeps moving and starts to move off on the other side of the sun, and then the sun, basically reemerges from behind the moon. I'm also going to show you guys a couple of pictures that I took in 2017 of the total solar eclipse that was visible in part of the United States. We had to go to Missouri to see it, but we did go see it. Okay, so this is a couple of photos from 2017 when we were trying to catch the total solar eclipse. The weather didn't really cooperate with us, but you can see two of my sisters, my husband, a niece of mine, all using their eye protection to try to catch the solar eclipse. I'll show you what I could get. Okay, so you can see that it's cloudy. We were really kind of afraid we were going to miss it, but you can see this is with my solar filter off of my camera because this is during totality, meaning it's during those few minutes that the moon is completely in front of the sun, and all you can see is that kind of purpley pinkish corona. Okay, there's also this picture that might be a little bit better, but anyway, that is a total solar eclipse. These are only going to occur during new moon when the moon is directly between the sun and the earth and is able to cast its shadow on the earth.